हेलो स्टूडेंट्स, आज हम स्टार्ट करेंगे अपना नया चैप्टर दैट इज सॉल्यूशन। अब सॉल्यूशन क्या है? सॉल्यूशन एक होमोजेनियस मिक्सचर है विच इज मेड अप ऑफ टू और मोर कंपोनेंट्स, बट हियर वी आर गोइंग टू स्टडी विद बाइनरी सॉल्यूशन। Binary solution. What is binary solution? Binary solution is that which is made up of two components, that is solute and the second one is solvent. Now what is solute? Solute, this is the component which is present in lesser amount and this is the component which is present in more amount. Now let us see an example. If we add 100 gram of water and 5 gram of sugar, then this is the solvent and this is the solute. Now we see the reverse of it, that is 5 gram of water and 100 gram of sugar. Now here water is a solute and sugar is the solvent. So from here we will consider that the component which is present in a lesser amount is always considered to be as a solute and the component which is present in a greater amount is always to be considered as a solvent. Now we are going to discuss the various terms with the help of which we can calculate the concentrations of our solution. Now here the first term which we are taking, that is mass percentage. Now what is mass percentage? It is the ratio of mass of solute over mass of solution. So its formula is mass of solute over mass of solution. As we are calculating the percentage, so here we are multiplying it with 100. Now what is the mass of solution? So it is also written as mass of solute over mass of solute plus solvent into 100. Now our second term is volume percentage. Now what is volume percentage? It is again the ratio of volume of solute over volume of solution into 100. Similarly, our third term is mass by volume percentage. Now what is this? This is the mass of solute over volume of solution into 100. So these are the three basic terms, that is mass percentage, volume percentage and mass by volume percentage. So now before moving further, I want to give you some terms which are really useful in this. Here in this, solute is to be considered as B, as we are taking the binary solution. So binary solution जो है वो दो components का बना हुआ है, जिसमें हम solute को B के साथ डोनेट करेंगे और अपने solvents को हम A के साथ डोनेट करेंगे. So इसके लिए क्या होगा? Weight of solute, that is WB, and weight of solvent is taken as WA. Similarly, number of moles of solute is equal to NB and number of moles of solvent is equal to Na. Further, mole fraction of solute is XB and that of solvent is XA. Volume we are taking with a capital V. Molarity. These are the terms which are using in this molarity. It is taken with a small m. And normality is taken with capital N. So these are the terms which we are using in these concentration formulas. So first of all, I am going to start with mole fraction. So first is mole fraction. So now its symbol is X. Now what is mole fraction? It is the ratio of number of moles of one component to the total number of moles of all the components present in a solution. So what is it? Ratio of number of moles of one component to the total number of moles of all the components present in a solution. So let us consider a solution be made up of solution of two components, that is A and B. Now let number of moles of A is equal to Na and that of B is equal to Nb. So from definition, mole fraction of A is Xa and that is equal to Na over Na plus Nb, because Na is the term whose mole fraction we are calculating, and this is the sum of the total number of moles of all the components in the solution, and we are taking a solution as a binary solution. Similarly, the mole fraction of B is Xb and that is equal to Nb over Na plus Nb. Now there is one important question, that is the sum of the mole fractions of all the components in a solution. So what is the sum of mole fraction of all components in solution? Now that is Xa plus Xb. Now what is Xa? Na over Na plus Nb. And what is Xb? Nb over Na plus Nb. Now taking LCM, Na plus Nb, Na plus Nb. Cutting these terms and that comes out to be 1. So therefore Xa plus Xb is equal to 1, and that is the sum of mole fraction of all the terms present in a solution. So similarly, if we are taking with the 3 terms or 4 terms like this, we can calculate the mole fractions of each and every term present in our solution. Now there is one important concept which is to be asked in your questions, that is whether the mole fraction change with the temperature or not. So here we can say that mole fraction not change with temperature. Now which components changes with the temperature? Only that component change with the temperature which depends upon volume. The concentration of only that terms will change with the temperature which depends upon volume. But in the case of mole fraction, volume is not present because we are taking here number of moles. Now what is number of moles? Number of moles are taken as given mass over molecular mass. So given mass upon molecular mass, as both the terms are of mass and number of moles, so therefore depends upon only mass of the terms. Hence, your mole fraction does not change with the temperature. So this can be the 1 mark question as CBSE had added your objective questions. So you will have to remember it that the terms which are independent of the volume, whichever the concentration is independent of the volume, that concentration does not change with the temperature. So now we are starting with next term, that is molarity. Its symbol is capital M. Now what is molarity, right? It is defined as the number of moles of solute present per liter of solution. So what is molarity? Molarity is number of moles of solute present per liter of solution. So as number of moles of solute, that is taken to be NB over V, and V is in liter. If we are taking it in milliliter, then it can be NB over V into 1000. Now number of moles, NB is equal to WB over MB into 1000 over V. So here the molarity comes out to be WB over MB into 1000 over V. Now what is WB? It is the weight of the solute. MB, molecular mass of the solute. V is the volume of the solution, and it can be multiplied with 1000 so that the values and of volume can be taken in milliliter. We are having more formulas for molarity. For example, in terms of mass percentage of solute and density. So M can be X into D into 10 over MB, where X is the mass percentage, D is the density into 10 divided by MB. Now our next term is that whether the molarity changes with the temperature or not. So molarity, as we can see in this formula, molarity depends upon volume. So अगर molarity volume के ऊपर depend कर रही है तो molarity जो है वो temperature के साथ change हो जाएगी. So molarity will change with change in temperature. So जैसे जैसे आप temperature change करते जाओगे, molarity solution की जो है वो change होती जाएगी, क्योंकि ये volume के ऊपर depend करती है. जो volume है वो temperature के साथ change हो जाता है. So here we can now see the molarity equation. Now what is the molarity equation? Now our molarity equation is M1 V1 is equal to M2 V2, where this is the initial term and this is the final term. So M1 V1 is equal to M2 V2. This formula you can use in your volumetric analysis. Now moving further to our next term, that is molality. It is denoted by small m, molality. So it is defined as the number of moles of solute divided by weight of solvent in kg. So number of moles of solute NB, weight of solvent, that is WA in kg. And if you want to convert it into grams, then it can be NB over WA into 1000. Now Number of moles are written as WB over MB into 1000 over WA. So this is the term for molality. Again, effect of temperature on molality. As we can again see that in molality, the volume is absent. So there is no term related to volume, as all these terms are of mass. So we can say that molality does not change with temperature. So molality temperature के साथ change नहीं करेगी. Hence, it is the best method to calculate the concentration of solution, because in solutions sometimes we need to change the temperature for the solution. So molality is better because it does not change with the temperature. If we consider with molarity, it changes with the temperature. So we have to face some problems while calculating the terms of molarity. So that it is better to consider the molality as best method to calculate your concentrations. Now our next term is normality. Normality. Its symbol is capital N. Now normality, it is defined as the number of gram equivalent of solute over volume of solution in liters. So gram equivalent of solute is weight of solute over equivalent weight of solute into volume into 1000. Now equivalent weight we can calculate that is molecular weight divided by the change in oxidation number of the species or acidity or basicity of the acids and bases. So to calculate normality, we can also use the formula of molarity, that is N into M, where N is considered as an N factor, which is again what? Yes, change in oxidation number, acidity or basicity of an acid or a base. And M is the molarity. So by calculating molarity first and then multiplying it with the N factor, you can calculate the normality. Now, the effect of temperature on normality. As the formula of normality depends upon volume, so we can say that normality change with temperature. So normality and molarity both will change with the temperature, whereas mole fraction and molality both does not change with the temperature. Now in the last, after considering all these terms of concentration, out of which mole fraction, molarity, molality and normality are the most important. Their definitions, their formulas and their numericals are very important according to the examination point of view. So in the last, I am giving you some formulas of all these terms related to each other, which will help you in MCQ. So these are the 6 formulas which will help you to to solve your numericals. That is relation between molarity and molality, molarity and mole fraction, and then the molarity of two solutions in which either two of them are acids or both the solutions are made up of two bases. And if we have a solution of one acid and one base, then the formula will be M1V1 minus M2V2. Here you can consider M1V1, whichever is greater. If the molarity and the volume multiplication of acid is greater, then it is considered to be as M1. And if the molarity and the volume multiplication is greater for a base, then it is considered to be as a base. So if the molarity volume term multiplication is greater for acid, you will get the molarity of an acid solution, and if it is greater for a base, you will get the molarity for a basic solution. Then is molality and solubility, and then the last one is the strength, that is mass of solute over volume of solution into 1000. So today we have discussed the topic, that is mole concept in solutions. I will post the numericals of this topic. You will have to learn all these definitions, these formulas by heart. So thank you, students. We will meet in the next topic in the next class.